The graph of that function on that interval is shown below. State the absolute maximum and absolute minimum values of the function on this interval. Okay, let's go for the obvious. There's your maximum, there's your minimum. So we are tempted to do something that a lot of students do, and we should not, okay? I am not going to say that the maximum is at -1. I will not. What I am going to say is, read it carefully, state the absolute maximum, absolute minimum values of the function, okay? So I need the value of the function, which is actually a y value. So the maximum value, yes, it occurs where x equals -1, but it also is going to really be, more specifically, at -1 comma something. So -1 comma, we'll figure it out in a minute. And minimum is here, which is at 2 comma something. Don't know what it is, but we'll figure it out. So very quickly, I'm going to type it in the calculator and figure out what it is. Actually, I know I've got an answer key off camera, but you don't see it. X to the third, sometimes I find it faster to do that, divided by 3 minus x squared divided by 2 minus 2x plus 1, and I want to plug in a -1 and a 2, and we get that. So I'm really going somewhere with this. You're going to see what this really all means in just a minute, but this is 2.16 repeating. In case you care, that's 2 1/6. And this is -2.3 repeating, which is -2 1/3. Now, excuse me. Pardon me for that. Where I'm really going with this is to talk about where maximums and minimums occur, and that actually happened on the previous side of these notes. Let me grab that for a second. I said things a few times, kind of alluding to what was to come, talking about, excuse me, that maximums and minimums occur where the derivative equals 0. I said that, like this is a maximum. If you drew the tangent line here, you'd have a horizontal line. They also occur at the end points of intervals. We'd be like, oh, look, there was a minimum there, right? There is another one as well. We'll get to that in a second. But I want to just demonstrate to you that, indeed, maximums and minimums occur where the derivative equals 0. So watch this. I'll make this quick. If we took the derivative of this, that's the same as 1/3 x cubed, which makes it 1x squared, so 1/3 times 3, minus, and then 1/2 x squared would make it 1x, and then minus 2. And if we set that equal to 0, because you can, because I want to, because I want to prove a point, x would equal 2 and -1. And so now we have candidates for potential places where we could have maximums and minimums, and indeed that is where that occurs. I'm going somewhere with this. Okay, let's look at the next one. State the absolute maximum and absolute minimum values of that function on that interval. Now, here's the tricky part. I'm not going to take the derivative of this one, right? Now, clearly I know the minimum value, and I know the maximum actually is here. And so let's just go ahead and do that. The maximum value is there. Now, you might say, well, what about this one? No. That is a local maximum. That is not the absolute maximum or global maximum. It's the excuse me, difference between saying, yeah, I have a high point versus I have the high point, okay? Just pointing that out. So yes, that is a high point. That is the high point. So maximum occurs at -1 comma 4, and the minimum occurs at 2 comma 1. And the point of this one is that while this one occurred where the derivative equals 0, this one occurs where the derivative doesn't exist. The derivative doesn't exist at this specific point. And, excuse me, something in my throat. And the maximums and minimums can also occur at the endpoints of an interval, which leads us to this very next one. So extrema, maximums and minimums, there's that vocabulary word. They occur in one of 3 places. They can occur where the derivative equals 0. They can occur where the derivative does not exist. Put D and E if you like. And the third one is that they can occur at the endpoints of an interval. Okay, it is at this point where it behooves us, I love that word, behooves us to put a very practical definition on paper, formalize it. So critical number, first time you've seen this phrase, excuse me. So a critical number basically encapsulates these first two. A critical number is where I have the possibility for a maximum or a minimum. And so here we go. If the derivative at some c value is equal to 0, or if the derivative at some c value, let me rephrase that. Let's word this a little better. Let's say that f is not differentiable. That's going to be a little bit better worded. Differentiable at some c value, then we can say something about it. Then c is a critical number of f. Okay, and critical number of f, a critical number is an x value. In a lesson or 2 or 3, we're going to talk about critical points, okay? Critical point would be a coordinate, like a location 2, 1. But if I'm talking about a critical number, I'm really referring to an x value. So let me slide the paper back up and talk about critical values. Critical numbers occur where the derivative equals 0 or where the derivative doesn't exist. Now, automatically you're saying, well, you're just pointing at extremely, your maximums and minimums. I know. Notice that these first two right here, these are critical numbers. And then the third criteria, the endpoint of an interval, may or may not classify as a critical number.